Hi there, everyone. My name is Ian Kwa, and today is the 3rd of December, 2025. As of this moment, I'm a third year PhD student in the Neural Systems and Behavior program at the University of Washington, and I am also one of the TAs for CSE 583, um, Software Engineering for Data Scientists. If you're a student of the class, please know that watching this video and working through this is completely optional. You are not obliged to do any of it. Um, with that said, let's talk a little bit more about this repository and what we're going to be doing today. So this repository is, you can think of it as a template for you to work through and practice refactoring code in a sort of like a safe and isolated environment. There's only one file here, main.py, which contains the contents. The rest of it are just, license files, README, the PyProject toml, and a UV file. There's only one external package, which is Logguru, which is a logging library. We may get around to using it, we may not, depends on how much time this takes. Uh, so on to kind of the impetus for this video, this exercise that I have here. I think that as a new developer, as a new or relatively new developer, as some of the students in the class are, it can be really useful to go through an existing code base with someone who has a bit more experience than you do. I think they can call out things that maybe you don't think to notice, which is fantastic, right? The primary downside of this is that unless you are taking a class specifically for something like that, or if you're doing, or if you are in an internship, you don't really get this experience while you're still in college, which is really unfortunate. Hence, this video and this repository. The way I see it, there are two ways to work through this. The first one is you go through main.py yourself, make all the changes you see fit, and then come back and watch the video as I walk through and explain my thought process. The alternative is you can work through small chunks and just, I guess, kind of see how your thought process lines up with mine. Or even, you might notice things that I don't even catch, which is entirely possible. Again, I've never looked at this code other than running a quick conversion script. The original code is in Python 2, and it's linked in the README, as you can see here. And the final solution will be in the refactored branch. All right, with that, I'm going to turn off my video, get a swig of water, and then we'll jump right in. All right. Hey, gang. We are back. Sorry about that. So, as I mentioned earlier, there are one, two, three, four, five files. This is on a fresh clone of the repository. You'll see I'm on the main branch. I can do a git uh, git fetch all. I have some aliases set up. This won't work on your end unless you install certain packages. Okay, and I'll do a git pull of the origin and already up to date. So perfect. Let's first create a refactoring branch. Okay, ls, and now let's take a look at the main.py. So there are a few things we can notice when we're looking through. The first thing is that we see quite a few numbers, and it's just six, right? These are known as magic numbers, and we'll probably want to address those at some point. Um, Here we have another hard-coded number, 50, and it looks like it corresponds to generating 50 questions across various, I guess, categories of things. Um, I forgot if I I forgot if I mentioned this already. We are using the random range function, the built-in function from Python. Um, okay, we are okay. Let's just scroll to the bottom really quick. They probably have a double underscore main, and they do. Okay, so it looks like the code is doing a few things. Um, Code is doing a few things. We initialize a game, we add a few players, and while true, until some condition happens, we roll a game. Uh, and there is some chance of maybe a user or a player having the wrong answer, and there's some other chance of the player having the right answer. And if not a winner, so if there is a winner, we break, at which point the game ends. Okay. So, I'm going to do two things. The first thing I'm going to do is I am going to split my screen. So I have two panes. Next thing I'm going to do is I'm going to actually just run the script to get a feel for what the output will look like. Okay. Uh-huh. So the first thing I already note is that there is quite a lot happening. Quite a lot is being printed to the screen, and I don't think we need all of this to be printed. So at some point, we will probably do some refactoring and remove the prints and replace them with logging statements. If you're not familiar with logging, we'll get to it in a bit, so don't worry about that. Um, so it looks like, from the code, we noticed they were adding a few players, Chet, Pat, Sue. Okay. Uh, the game is probably initialized here, where Chet is the current player. They roll a certain value. Chet has some new location, and there's a category associated with it. Uh-huh. And then Chet incorrectly answered it. Okay. So uh Chet incorrectly answering it probably corresponds to this two lines of code. And it looks like it just continues on and on and on and on. um until Pat has six gold coins, at which point it seems like the output stops. So presumably someone has won the game, which is great. Okay. Um, cool. Let's now so we're pretty fortunate here in that the code is only about 177 lines of code long. Um, because there is some randomness, we because there is randomness, our runs will be inconsistent. So, now Sue has won, no, and now Pat has won again. What we can do is we can set a random seed so that we always have the same outcome. The advantage of this is that, at least for our current application, we don't have to write any tests. Give me 1 second. Random seed Python. Random dot seed, and you specify a value. Okay. Okay. And perfect. Uh-huh. proceed and let's say 42. 42 seems to be a canonical number that a lot of programmers will default to when they're too lazy to think of another number. So, okay. And just to prove to you, we now get the exact same output every time we run it, which is great because what we're not gonna write tests to verify correctness. We're actually just going to check that our um, diff is the same with the original output. So what we're going to do is we're going to do Python main, and we're going to output the results to original results.txt. Okay, and now we're going to just access the file, original results, just to make sure it's properly populated. Okay, we see Chet was added, and at the very end, Chet has 6 gold coins and is the winner. So what we can do is then later when we run this again, we can output it to new results.txt and diff new results.txt and original results.txt. And if they are the same, we should see no output, which is exactly what we see here. Fantastic. Okay, so let's start refactoring some things. Um, I think the first thing that I really want to tackle is the first thing that I really want to tackle is game.roll. We see a ran range here, ignore the start equals 5 there. I think there's something wrong with it because the first argument to rand range should be the end value. So I need to figure it out at some point, but it is outside the scope of right now, so don't worry about it. Okay, so we initialize, let's go to the initialization. We initialize some number of players, some number of places. I think that corresponds to I think there's a game board associated with this game, and the number of places is how far ahead a player will jump based on some of the output that we saw earlier. Um, Purses, I think purses corresponds to a given player. So, in theory, I think there should be the same number of purses as there are players. So that's definitely something to take note of already. In penalty box. Um, in penalty box, let's take a look here and see. No, T. Okay. Uh-huh. Penalty box. Question was incorrectly answered. Okay. Okay. So here, based on this line and just doing some quick searching around, we have a case where Sue is a current player. Sue rolled a 2. Presumably, Sue's previous location was 8. I can check that in a second. Sue's new location is 10. Category is sports. It's the third sports question. The question was incorrectly answered. Sue was sent to the penalty box. Okay. Uh, so penalty box does seem to correspond to every player in the game. Um, I think purses, if I had to guess, is related to the number of it's related to the uh, number of players in the game. So that's definitely an issue. And let's look up Sue. Sue has 3 gold coins, and Sue's new location is 8. Okay. Okay. So yeah, so I think the role corresponds to the number of places forward the user will move, I think. So let's come back here. Uh-huh. Um, so the first thing I'm going to do, and this is just a hunch, This is why you always write tests, but because I don't want this video to get too long, we're gonna skip tests and we're gonna do that thing I mentioned earlier where we just sort of wing it. All right, so num layers. Uh, oh, okay. I see. Okay. Um, we're going to, so we know for sure that purses is uh, we know for sure that purses is associated with a user, and we know that in penalty box is associated with a user. So if there is no player, there shouldn't be a purse or an indicator that someone is in a penalty box, right? It just wouldn't really make sense. Places. Places. I am not sure what places is for just yet. We'll come back to that. Current player is getting out of penalty box. Let's just move that up there. So we'll notice that all of these following lines are related to initializing a container for the questions and simulating an actual question. So what we can do is we can create a new function, initialize questions, and ideally we have some parameter, num questions int self. Okay, so we have the number of questions that we want, questions. So that's fantastic. We've sort of cleaned up a little bit of code already, and now at the end, we're just going to initialize the questions, num questions, and one of the input parameters can be just num questions. It'll be an int. Earlier number of questions was already specified as 50, so we're going to do the same thing. It's 50. Okay, so we have that. Another thing we'll notice is that here self.rock_questions append create question. Um, we have a few options. One option is we remove this function and just do a copy paste of it. We do a copy paste of another question and we just simplify it that way. The other option is you can sort of like refactor all of this to dynamically accept a series of categories like pop, science, sports, rock, math, physics, and based on the parameter of the number of questions, it will automatically populate um, each of these containers. But it also depends on what exactly your end goal is. Like for some use cases, it might just not even be necessary. Okay. So we've taken a look at the initialization. That's great. And now we want to take a look at role. So here, line 172, we are rolling some number. Presumably, role is an integer. So I'm just going to annotate it really quickly just for our LSP. LSP is a language server protocol, or if you use VS Code, it's probably already set up for you. If you use PyCharm, also already set up for you. What the LSP does is it adds type hints, so it's just really useful, right? Let's say this wasn't, let's say for example, this function, how many players wasn't actually named how many players, it just said players, right? Um, that context is really ambiguous. It could be the name of all the players, it could be the number of players, etc. But if your code has len self players, if your LSP is smart, it'll automatically infer that it should be an integer. So if you use it down the line anywhere where an integer is expected, it will sort of like verify that it is a valid input. If you try and use it somewhere where, for example, you expect a string, your LSP will tell you, hey, uh, this downstream function expects a string, but you're passing in an integer. It's very useful. It saved me a number of times. I highly recommend getting it set up. But anyways, so let's take a look back at role. So we have some logging, some information display about who the current player is and what they rolled. We then have a check to see if the player is in a penalty box. Okay. If the roll was even, they are getting out of the penalty box. Fantastic. Huh? They move self places, self current player, self places. Okay, so the player moves forward some number of steps, some number of places. If self places self current player is greater than 11, self places self current player resets to 0. Uh, resets to, I see. Okay, so this is if you're not familiar, this is modulo arithmetic. Uh, so basically, if the player is at step at place 10, right, and they roll maybe a 4, they will go up to place 14. But I guess the way that the code base is set up, there are only 12 valid spaces. So we want to wrap around. So you can do a sort of like modulo arithmetic. It's like clock arithmetic. It just sort of like loops back on itself. Okay, okay. And then we print out the player's current new location and whatever the category is, and then we ask a question. If the player is in the penalty box and they're not getting out, then it looks like we don't ask them a question. And in the case where they're not in a penalty box, I'm guessing they just get asked a question with a lot of the same logic. And we can see that here. Okay. So something I am thinking is that the other than this very specific print statement about getting out of the penalty box, right? You notice this code is identical to this code. So what I'm thinking is we can probably extract out we can extract out the common functionality here. And we can do that by doing this. So if self player in penalty box, self current player, and roll mod 2 equals 0. So now we're falling into the else case. We're falling into this case. So we can delete that, move that up, paste that in, move that there. Okay. So if the player is in the penalty box and they are not getting out, so they are a even number, they're not getting out, and we just skip their turn altogether and we just return here. And here is the implicit else case. And we can just reuse all of this logic. Self in the t box of self current player. We print that they're getting out of the penalty box. And now, well, now all the rest of the code should be the same. Oh, so we've done quite a bit of coding. Ideally, I should have been testing this a lot more as I went along, but let's just run this and see what happens. Whoops, that found me. We forgot to specify the number of questions that we want. Questions. And actually, now that I think about it, this isn't going to work yet either, because every time we append a player, we need to how many players? That's how many players? So I see. Okay, okay. So okay. How many players? Okay, I'll just do this really quickly. So self players is a list of strings containing our the player names. Uh, places self how many players equals 0. Self versus I see. So self dot. So there is always a place corresponding to a player. Okay. I'm not sure I understand that part. But we'll come back to that. What I do know for sure is that when a player is introduced to the game, we want to append a new 0 to the purses because new player has a new score card tracking thing with them. And self.in penalty box. Append false. Okay. We'll need to come back to places in a bit. I'm still not 100% sure what's happening there. Self purses, self how many player. Aha. Okay. Mhm. Mhm. We can see the error. It happens on line 163 when we try to add chat. And so when the code then goes and looks at line 163, add 163 and 41. So let's go to 163. We added a player chat, and here it goes to line 35, and it's saying it errored out here versus so players 0. And the reason why this is causing an error is that it's trying to index into more players than we currently have. So we can actually just delete that line because that line is basically, in a sense, redundant with this line that we have here. Hmm. Hmm. Ah, sorry. So I think the issue is that so when you do a single pipe that inserts into a file, it clears out the original and it inserts in. If you do a double arrow, it will append. So yeah, so that's what we see now, which is fantastic because that means all our changes so far have been correct. That's great. Good news. At this point, I would say, hey, let's do a commit, and that's what we'll do. And we refactored add, we made add cleaner, and we refactored role. So git status, git add main. We don't want to add the new results and original results because, what's the point? It's just validation for us. Git commit dash m refactored add. function and role function. Perfect. So now if we mess something up, hopefully we don't, but if we do mess something up, we can just return and figure it out from there. Okay, so after if the player is not in the penalty box and all of that, um, they will be asked a question. So now let's take a look at the current category. Okay, so ask question if current category is pop, we will print the popped value. Okay, so we'll pop the very front of the list and we'll just work our way down through the 50 questions. That's cool. Sure. And here, property, um, the property is basically a function. It's known as a function decorator. What it does is it allows you to call the current category function without closing the bracket, without the parentheses around it. And so this version instead of this. Uh, when do you want to use that? You typically want to use that if, for example, you have when you want to use that, you typically want to use that when you have sort of like a property of something. I think the typical implication is that a function call maybe runs computation on the fly, whereas, like current category, in theory, you could track that manually, or you could just have a really simple function, I guess, that does this. Um, that said, let's take a look at the current function, the current category. Okay. So self dot places self current player equals 0. It's pop. If it's 4, it's pop. If it's 8, it's pop. If it's 1, 5, 9, it's science. 2, 6, 10, it's sports. So presumably 0, 1, 2. So presumably rock is just 3, 7, 11. I think that's right. 2, 7, 8, 10, 11. Okay, perfect. And that presumably is why we have the clock arithmetic. It's why up here we only let the player go up to 12. And I think that's actually rather silly. Okay. Okay, perfect. Great. This is great to know. So there are 12 possible places the player can be in. And that means that, earlier I was kind of worried about places here because I thought, okay, I'm not sure if places corresponds to maybe where the player is on some fictional board or if it corresponds to the index of the current player. And this tells me that all players start at 0. Um, and we can now come here and self.players append 0. So every time a new player is added, they start off at the 0th spot. Versus is a list of int. In penalty box is a list of bool. Current player is an int. Bool and places is a list of int. Perfect. Lovely. That's so great. Okay, is playable. Function add. That's interesting. Oh, okay, so this is a perfect other learning opportunity. Um, so is playable. I don't recall seeing is playable used anywhere. Okay, yeah, is playable is not used anywhere. Um, Presumably is game dot is playable uh print too few layers exclamation. You're very angry and you just exit. Okay, so that was a function that just was not being used. I did not remember seeing it, so we ended up just using it, which makes sense. We were going to need to use it anyways. Versus players. Okay, so we have a player's container, a purses container, in penalty box container. We have a player's container, places container, in penalty box container, versus players, purses, in penalty box, and then finally places. Excellent. Um, I think we should be fine, but we can just do a quick git diff and check all the differences. So we have added some type annotations at the top, which is good. We've removed self places, self how many players as zero because we know that every new player who joins is initialized at the zeroth place. So, it doesn't really matter. We added an annotation for the number of indices for rock, and from there we also realized, oh, the reason we only allow up to 12, as we see here, right, is because there are only 12 sort of like 12 not 12 categories, but 12 locations that a player could be. So I think I actually I'm not a huge fan of the code as is, well, for obvious reasons, but I think one reason in particular is these three lines. Uh in these three lines, you are updating the state of the player, right? In a sense, is that related? Is that specific to role? If a player is not rolling, do they move? Okay, I'm putting the cart before the horse. Let's not worry about it right now. Um, let's do a quick overview of what we've done. So far, we have modified the init to take number of questions, which is to pre-specify some number of questions that we want. We then defined a new initialize questions function, which allows us to um, create the questions in, I guess, a more clean way. Arguably, you don't have to do this. It's a pretty short file, but I think it can be useful. Um, my code editor does not support code folding, but if yours does, it probably does. You could just fold all of this so that it only appears as a single line. And that makes it nice. It's a bit cleaner. Um, we've done that. We've used is playable. We have modified the add so that we are not hard coding the maximum number of players or purses, etc. We are just incrementing or growing the container as needed. We modified the role so that a lot of the redundant logic was removed. and we took a look at ask question, huh? And we figured out what that did. And then now we are at current category. So, unfortunately, this code is a little bit messy. I'm going to be honest with you. Um, I think we can do better. So, we can do this. Oh, so if the current place that a player is in is either 0, 4, or 8, we just return pop. And if the current player is in 159, we return science. Oh. If the player in 2, 6, 10 return sports. If self.places, self.current player in 3, 7, 11 turn raw. Else, if somehow um, something happens, right, we will just raise exception. You should, well, okay, no, I'm not going to do that. Class. Let me see how to create a custom exception. I don't really remember. Custom exception, Python. Okay. Class my exception pass. Okay. Okay. So we do class game exception pass. And now we will just raise a game exception. Raise game exception encountered a location that encountered a player in a place that was not valid. What we could do, in fact, is add more information even. So current, let's do error string equals, and this is what's known as f-string formatting in Python, player, and we'll add the name even, self dot players, player, in invalid place. And self dot places, self dot current player. And now we will just pair string. Perfect. So what we've done so far is we've refactored the code so that it's just cleaner here, right? 048, 159, blah, blah, blah. You don't have to trace through all the different conditions. And we have also, so my editor was complaining at me. The reason he complained at me was that we, had a return here, right? And we had an else. You don't actually need a else if you have returned in the previous case. Uh, yeah, it's I think it really depends. I think some people do prefer if it's explicit, and some people don't really mind. I generally don't mind. I was just trying to be very clear just for pedagogical purposes. So anyways, we raise a game exception, and I guess we really only have two more functions. So let's just check really quick that we're still on the right path. Fingers crossed. Excellent. Okay, so git add main. Oh, wait, no, let's just do a git diff real quick. Okay. We refactored current category and we added a descriptive error message. Git admin, git commit dash m, okay, GCM, refactored current category and added descriptive error message. Hmm. Um, ah, I have so many aliases on my machine that I get myself confused sometimes. Don't do that. Okay, and now here we are, home stretch. We have two more functions. Was correctly answered and wrong answer. And did player win? Uh, you know what? Given the length of did player win, let's just check that out really quick. So return not of self versus self current player equals 6. So if the player, I guess, has 6 correct answers, that means they win. Um, if you're familiar with Boolean arithmetic, we could just push the not into the statement. So instead of equals 6, we could just have it as not equals 6. And that's just a lot cleaner and makes it easier. Another thing to note is that the 6 here, right? Where did that come from? Uh, I have no idea. Presumably, the person who made this game before me has specific reason. So let's just say uh, coins to win equals 6. And now we can do not equals coins to win. Okay, let's take a look at wrong answer. Okay, so it prints out that a question was incorrectly answered. Sure. Wrong answer, good function name for that. Uh-huh. And it says that someone was sent to the penalty box. Okay. We then mark the player as being in the penalty box. We go to the next player and we ensure that the current player. I see. Okay. So basically, this goes back to the clock arithmetic I was mentioning earlier, where we just want to make sure that the next player is a valid player in the sense of, let's say we only have 3 people. Um, the last person in the group answered incorrectly. We're not going to give the turn to someone who's not in the game or someone who doesn't exist. We have to make sure that it's, I guess, someone who does actually exist. So, as I mentioned before, modular arithmetic again. So, what we can notice here specifically is that if self current player equals length of self players, self current player equals 0, right? We actually already have a property here of how many players. So we could just reuse that. So if self dot current player equals self dot how many players, self current player equals 0, right? What we could also do is self current player plus equals to 1 and self dot current player modulo equals self dot. Okay, I'll write it out instead of the shorthand. Current player modulo self dot how many players. Perfect. And with that, we are down to one last function. The function where, if was correctly answered. That's going to be a bit of a doozy. So, let's just check, make sure everything is still correct. Perfect. Everything is still correct. We are good to go with the final portion. Um, I recommend git adding and git committing more often than you need to, because at the end of it, you can just squash all your commits together anyways. So there is no reason to be precious about them. If git diff hash. Okay. And we just made some quick changes. So uh, git commit message. Mm-hmm. Better check of for winner and modulo arithmetic for players in game. There we go. Lovely. Now we can take a look at was correctly answered. Okay. So if the current player is in the penalty box and they are not getting out of the penalty box, and they are getting out of the penalty box, we say the answer was correct. We give them an extra point, okay? Our intuition earlier about the purses corresponding to the number of points or the gold coins or just some winning condition uh, holds. Fantastic. Okay. And we then evaluate if the current player won. We increment the turns, and then we return if someone did win. Presumably, it's exactly the same here. Okay, answer was correct. Current player +1, print. Someone now has so many gold coins. Check the winner, increment player, return winner. Okay, so we can do what we did before, right? uh, we can negate this condition and extract it, and not self dot is getting out of penalty box. Uh-huh. Nope. Let's pull that in. Okay. And we just extract this out. Uh, okay. Say a little prayer. Uh-huh. Okay, perfect. We see the only difference here is that there was a misspelling in the original code. But other than that, I think we are all good. Yeah, excellent. Yeah, so I think we are at the end. We're near the end. Um, and I guess just for completeness, we'll finish it off. Um, okay, from staring at the code for quite a while now, I have two guesses, right? The first one is that this is a dice roll, and the ran range, my LSP is, I think, misinterpreting it. I think this should be stop instead of start. Stop meaning uh, it it generates a range of values from 0 to 5, not including 5, and it just randomly picks one value in it. And because it can be 0, we we increase the offset by 1. Um, what we could do here is just dice min equals 1, dice max equals 6, and we can start at dice min dice max. Well, okay, that is embarrassing. um, no idea what happened with my editor earlier. That I think that might be the first time it's ever happened to me. And of course, it happens like while I'm recording a video. So that's just great. Um, okay, we have some min and some max dice roll, and we have some random range equals 7, wrong answer. I guess 0 up to 9. Okay, so as I understand it, this is basically just a way of simulating someone getting an answer incorrect. Uh, I think we can refactor this better. Uh, uh, we can say this is outcome equals, okay, if outcome equals, actually, outcome's not really a good one. I think possible outcome. And this is failure possi failure condition. Okay. If it was in the failure condition, the user was incorrect, else it was correctly answered. Okay, let's just try that again. Okay, the it's still the spelling issue. I don't want to update the original test file, just in case. I guess I could. It's not a huge issue. If not, not a winner, break. Okay. I think that is most of what we had for today. Um, there are a few other things I see, someone could do. The first is, as I mentioned earlier, maybe you could accept a list of categories. So categories, list of stir, and the list would contain strings of, like pop, science, sports, rock, math, space, and it would automatically generate different questions, right? Um, Another thing I could see happening is you could do modulo arithmetic for this. You could even extend the current category, to accept um, maybe many different states, which correspond to many different categories, and it's all dynamic. That's another option. I think that could be really fun to implement. Um, what else could you do? You could, and I think this might be really good practice, um, at logging into your code. So let's, as a quick reminder, right? Like this is what happens when we call the main function. We see a lot of information. Logging would basically allow you to specify, okay, do I only want to see warnings? Do I only want to see errors? Do I only want to see uh, high level information? For example, science question 0, right? Like I don't need to always see that. That's maybe not important. Um, I don't need to see, sports question 0. Maybe I don't even need to see what category we're currently on, right? Maybe all I need to know is when someone has new gold coins or when an answer was correct. So depending on your specific use case, you might add different logging levels. I'm not going to go into it. I think you can use that as an exercise for the viewer, if you will. And I think that's all we have for today. Um, oh, and also you could just update this RAND range to specify some number of possible states. Maybe you don't only want one possible failure condition. Maybe you want to specify some sort of uh, let's say in a sense, this is a bias coin flip, right? For the failure condition. So you could just have something more direct, maybe like a rand int instead of rand range to make the meaning more clear to another reader. And I think that's kind of all we have for today. I'm just going to stop sharing. Thank you so much for joining me in this refactoring process. If you have any questions, feel free to post on the Canvas, assuming you're taking the class this quarter. If not, feel free to comment on the YouTube video, add a discussion on the GitHub. I'm happy to engage with you there. And with that, goodbye.